Hey there. This is a video about some practice. Now, we're going to put everything together. And so what I'd like to do in this video is get all of the rules that we've talked about in the last couple videos, last three videos, put them all together and make sure that we have a very, very good concept of what's going on before we start adding and subtracting and dividing and multiplying these things called polynomials, all of which involve exponent rules. So in this video, we're going to do the examples on the board plus one more that I want you to work on. I'm just going to be modeling my thinking, like how I would approach it, getting all these things down and really focusing on what we do is one level below what we see. That's what happens with exponents, and exponent rules only apply to exponents. So I'm going to be talking a lot about that as we go through the examples, and we're going to start right now. So there's really not much that I need you to learn, just how to apply what we've been learning. So firstly, we have an example here in exercise that number one thing that I want you to see is when we're dealing with all these operations, order operations is still relevant. So when we look at this and we go, well, what do we do first? Parentheses. And if there's nothing to do inside the parentheses, then exponents. Hence, we're going to have our exponent rules. Then multiplication, division from left to right. Then addition, subtraction from left to right. That's the idea. So when we look at this, hey, I do see some multiplication. But I also see that before that, I have some exponents that I need to take care of. So now our exponent rules start kind of kicking in. So when I'm looking at this, I am seeing multiplication. I'm also seeing exponents. Now I ask myself some questions. Can I distribute exponents? Yes, across one level below exponents, across multiplication or division. So I see that. I see some multiplication. I see some multiplication. Now, in order to distribute exponents to those factors, we have to use another exponent rule called the power rule. That means that every factor needs to have an exponent. If it doesn't have one, you have to give it one. So I'm looking at multiplication. I go, well, exponents has to happen first by order of operations. Can I distribute? Yes, across multiplication, one level below. What do I do? Well, exponents raised to exponents, one level below that is, I'm going to multiply my exponents together. So I keep my base, I multiply my exponents. 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 So I've done exponents first. I said, well, we can distribute across one level below, that's multiplication. I'm seeing an operational level of exponents. I need to multiply my exponents. I never multiply exponents times bases. That is not what we're talking about here. The exponent rules only apply to exponents, not to multiplying bases. Now, I might simplify a little bit. I know that 5 squared is 25. 2 to the third is 8. And now we have something pretty reasonable. Let's multiply. Now, when we start multiplying, it's very important not to get our rules confused. If I want to multiply numbers together, that's fine. Exponent rules do not apply to multiplying those factors together. That's just going to be, what is that, 200? It does apply to multiplying anything with our exponents, though, that have common bases. So I'm looking at this. So the whole time through, I saw distribution, put it across multiplication division. That's great. I saw exponents, I'm multiplying my exponents. I'm seeing multiplication. One level below multiplication is I'm going to be adding to my exponents. That needs to be x to the 5th, not x to the 6th. That's the idea. That's the correct answer. Next up, well, I don't see any exponents operationally that I can do, but I do see some multiplication. So I'm going to start multiplying. Oh, maybe I do have an exponent I can do. So y to the 7th I can't simplify. Y to the 3rd I can't simplify. Y to the 0, well, y to the 0, that's 1. So I have common bases being multiplied. What I do with exponents is one level below what I see. That's y to the 10th times 1. Anything times 1 just gives you the anything back. It's multiplicative identity. Just going to give you back y to the 10th. Next up, that's a nasty one. That's a lot of stuff going on. Where do we start? Well, it's actually really similar to that problem in that I have multiplication, I just can't touch it yet. I've got to do our exponents first. So I'm going to look at distributing exponents across, one level below is multiplication, across multiplication. What that means, I've got to show all the multiplication here. Now, I taught you last time in the last video that with any negatives, it's oftentimes a real good good idea to separate the negative out. That way we don't accidentally group it with an exponent that we shouldn't. Also, because exponent rules only apply to exponents, if I'm going to use an exponent, I have to give everything an exponent. Every factor that you're distributing to has to have an exponent to distribute to. So it's got to have that. So yes, I see some products here. -1, +3, a squared, b to the third, and now I have everything given in exponents. So first power, second power, second power. That's so that we can distribute our exponent across multiplication correctly. And when we do that, we're going to have exponents being raised to exponents. If I do exponents raised to exponents, one level below that is multiplication. 1 times 2 is 2. 1 times 2 is 2. Never multiply bases times exponents. A to the 2 times 2 is 4. B to the 2 times 2 is 4. That already took care of our first expression. Now the second one, we're just going to tack it on by multiplication. That's cool. I would show some products. I know that exponents distribute across multiplication, one level below. I know that we can show all of our multiplication up here. I know that in order for exponent rules to work, I have to show exponents. That helps me to not accidentally multiply 5 times 4. Instead, I go, yes, that 4 is going to distribute to the exponents of all of these factors. When I distribute exponents, one level below that is multiplication. So I'm distributing across multiplication. I'm also viewing that the level of exponents, I would multiply the exponents to get our correct answers. So 5 to the 1 times 4, a to the 1 times 4, b to the 2 times 4. When we deal with exponent rules, we do one level below what we see. If you're seeing exponents, so in order to distribute, you're seeing exponents raised to exponents, that's what that means. You have to multiply those exponents together. After that, well, -1 to the second power is +1. 3 squared is 9. Maybe simplify a little bit as we go. 5 to the 4th power, let's see, 5 squared is 25. Another 5 squared is 20, 625. Now, let's multiply all our numbers. Remember, exponent rules don't apply to the multiplication you're used to. We're just going to do 9 times 625, so whatever that happens to be. Looks about right. A to, now we're multiplying common bases. We're seeing multiplication. What we do is one level below what we see with our exponents, not with our numbers, but with our exponents. So I'm seeing multiplication, I will add my exponents. I'm seeing multiplication, I will add my exponents. I'm going to double check that one real quick. Yeah, it looks about right. So that's our final expression. Now, which one's easier to deal with? That is. Because if you had to plug in 2 numbers for A and B, you'd have to plug them in twice here, figure some out, twice here, figure some out, then multiply. That's a lot harder. You could plug in the same 2 numbers here and get exactly the same answer. We're basically just simplifying. Now, we also determined that what we distribute across needs to be one level below the operation we have, which is why when we distribute exponents, it's got to be across multiplication or division. When we distribute multiplication, it's always across addition or subtraction. Well, that's what we have. So we can distribute. Distribution is a multiplication concept. So when we distribute, we're going to be multiplying. So you're seeing multiplication. If I'm seeing multiplication, notice how the exponent rules don't have to do with our numbers. So this can be kind of a point of confusion for a lot of students, but wait a minute. You gave every number an exponent here. Yes, because when we distribute exponents across factors, they go to the exponents of those factors. When we distribute terms across terms, you end up multiplying. You're just multiplying. You're not having an exponent operation. So we don't need to take exponents to the exponents of our coefficients of these terms, because that's inherently done when we multiply. We're just multiplying numbers times numbers here. So we drop down a level. We don't need to show all the powers for our coefficients. We're simply multiplying x to the third times 3x to the first. The numbers themselves get multiplied here inherently. We're not raising anything to a power. We're not doing any of that. Here you were. You were raising everything to a power. Every factor was being raised to a power. Here we're not. Here we're just multiplying terms times terms. We're not raising that number to any power. We're actually just multiplying a number times a number 1. So when we're seeing multiplication, we let our numbers multiply. 1 times 3 is 3. When we're seeing multiplication, okay, see multiplication, one level below is I have to add my exponents. X to the 4th. Minus, cool, minus. 1 times 5, okay, that's a 5. X to the 3rd times, y to the 4th. I can't combine those. So if I don't have common bases, I'm seeing multiplication, but they're not common bases. I can't add my exponents. We just leave them. And then we're done. We can't go any further than that because in order to do anything with our exponents, in order to add or subtract them, you'd have to do what's one level below. That's nothing. You'd have to have exactly the same exponents to not do anything to them in the next step, to add them and not change them. So we're done. We can't go any further than that. It's kind of nice. You know what? What I'd love for you to do is try the next 3 on your own. It's very similar concepts, but try the next 3 if you can pause it or just kind of, as I'm erasing this, I'm going to write one more example up there. See if you can do those. If you want to try a hard one or more difficult, try that one too. That's kind of nice. So last 3 before our tough one. When we're doing this, we are always following order of operations. So we're looking to distribute exponents first across multiplication and division only. Then we're looking at doing multiplication or division, and then finally addition, subtraction. So I don't have any exponents that need to be distributed. What I do have is really just a multiplication problem. That's all that's there. Looks a little more confusing than that, but it's just multiplying. So we don't have any distribution. We simply have a multiplication problem. Our coefficients are 1 and -1. So when we multiply, you can still do the multiplication like you normally would. 1 times -1 is -1. I know our answer is going to be negative. It is very relevant to give every factor of common bases an exponent, so you don't forget it. So we have numbers times numbers is -1. A squared times A. And you could write all this out if you wanted to. If you need to do that, go ahead and do that. Everything's multiplied together, but we notice -1, we have A squared times A to the first. I'm seeing multiplication, I'm going to add one level below. B cubed times B squared, I'm seeing multiplication, I'm going to add B to the 5th. That's it. There's no more that we can do on that problem. Next example, I very much would love it if you would separate that negative. Now, the first operation that we see here is exponents. Now, when we deal with this, I know I gave an example where we didn't write an exponent above a number. That's because when you're dealing with exponents, those things have to distribute to everything that's being multiplied together. When you're distributing multiplication, you're just taking terms times terms. We're not dealing with the exponents of our constants, of our coefficients, of our numbers. We are here. So when you're distributing exponents, you do need to put exponents above your numbers. That's how we would distribute exponents. Exponents can only be distributed to things with exponents. And the way that we do that is by multiplying those exponents. So you got to have them. When we distribute like we did earlier, and we distributed multiplication across addition, subtraction, we're multiplying terms times terms. We're not affecting the exponents of those coefficients, those numbers. We're not doing that, so we don't need them there. Only when you're distributing exponents across lots of factors do you need to put exponents on your constants. That's it. Now when we do that, we have 1, 2, 3, 4 factors are going to get our new exponent. So we're raising exponents to exponents, every single one of those 4 terms. That's -1 to the, remember, exponent rules only apply to exponents. That's why we had to have them. And how we do that is one level below. So we see exponents, we multiply. We see exponents, we multiply. We see exponents, we raise the exponents, we multiply. And again, we're going to multiply. Now we simplify. Negative 1 squared is positive 1. 3 squared, that's 9. R to the 8th and t to the 6th doesn't change. We're going to make it look a little bit nicer. 1 times 9 is 9. And we're done. That looks good to me. I hope that you're seeing the interplay and the differences between when we're distributing across addition subtraction, we don't need to put exponents above our constant factors, our coefficients, because we're not changing those exponents at all. We're not even moving exponents across those. When we're distributing exponents across factors, we certainly are. That's when we need our exponents above our coefficients, our numbers. Last one, we've done a couple of these. I just want to make sure it's in your head. You are multiplying. You're multiplying the exact same base. We do need an exponent up there. Just don't distribute the exponent across addition and subtraction. I am begging you here. We can't distribute exponents across more than one level below. So multiplication, division, sure, but not across addition and subtraction. What we actually have here are common bases being multiplied. I'm seeing multiplication, one level below. Let's keep our base the same and add our exponent. Don't give me that. Do not give me a to the third minus b to the third. It never works. It doesn't work that way. So that would be distributing exponents across addition subtraction, which is a blatant no-no. Multiplication division, yes, that's one level below. All this stuff is one level below. If you haven't done it already, I'd really like you to try that one. I'm going to go through it kind of quick, but I'm going to talk about everything we've learned so far in this besides the zero exponent rule. The first thing, order of operations is imperative. We know that we're multiplying here and here, but we also see that exponents need to be, well, we need to do our exponents first. That's the first operation that we have. So in order to deal with that, I'll probably write this out a little bit different. Take my time on it. And write out exactly how many factors are being multiplied in there. We're going to do the level of exponents first, that operational level. And we know that that distributes across multiplication, not addition, subtraction, but multiplication. In order to distribute across multiplication, your exponents need to affect exponents only, and it needs to affect every single factor in there. So I'm showing every factor they have, negative 1, 2, x squared, and y. Every single one of those has to have an exponent to use exponent rules when we're applying exponents to factors. Doesn't work so much on when you're just distributing terms by terms. Exponent rules are there, but not for the coefficients. We don't have to worry about that. Same thing here. I'm showing every relevant factor. I'm giving every factor an exponent so that I can distribute exponents onto those factors. Now, we actually do that. So I'm leaving my 3. I haven't forgot it. I distribute, I get negative 1 to the 1 times 3 is 3. I'm seeing exponents. I'm going to multiply those exponents together. 1 times 3 is also 3 for that 2. I'm seeing exponents. I'm going to multiply those exponents. X to the 6th power, 2 times 3 is 6. Y to the 3rd power, 1 times 3 is 3. Next we have 4 to the 2nd power. Cool, I'm seeing exponents. I'm going to multiply. This is why we had to give that an exponent here, because we're applying the exponent onto that factor. We don't change bases with exponent rules. We only change our exponents. Here we have to multiply. X to the 2nd and y to the 8th. What I was talking about earlier was this. There's a difference here. Why we don't need to put those exponents there is because when we start multiplying, it would take common bases to even do anything with them. We're not using exponent rules with our constants there. When we're multiplying, we're just multiplying our numbers together. We don't have to change the exponent of those coefficients. We're not doing anything with that. Here we are, because those exponents, this exponent can only affect the exponent of our factors, hence we have to have one. These exponents don't affect nothing, because we're not taking exponents to exponents there, which is why we don't have to show it, in case you were wondering. Now that I've distributed my exponents appropriately across multiplication division by using my power property, exponents to exponents I'm multiplying, we're going to simplify, just slowly. 3, we keep the 3. Negative 1 to the 3rd power is negative 1. Let's make this 8. Here we've got 16. Be careful. I mean, it's real easy to go too fast and get stuff like 8. That'd be a problem. And lastly, let's multiply all these numbers together. So I know that our answer is going to be negative. I know that this is 24. 24 times 16, well, let's see. 384. Yeah. And then hey, we have multiplication now. I see multiplication. I'm going to do one level below. That's add my exponents for every pair of common bases. 8, 11, and we're done. That's where I need you. You see, we get some of the stuff moving forward, but if you know exponent rules, it's not a big deal. What we do is one level below what we see. What we distribute across is one level below what we have. We need exponents to distribute exponents. We don't need to show exponents for constants when we're distributing terms. That's a little minor difference there. Next time we're going to talk about how to add and subtract these terms. We're going to call them polynomials. We'll talk a lot about what like terms are. We'll find it to describe for you why we can't add some of these exponents together or change our exponents when we're adding and subtracting. We'll talk a lot about that. I'm really hoping that this is sinking in, that you really get the idea. I kind of beat it to death in this video. Like, we did a lot of examples for a long time to make sure that it did. Work through them again. Do them on your own. If you didn't stop and pause the video and try them on your own, maybe do that now. Pause it, write them down, see if you can get the same answers that we got. Hopefully they're all right. And I'll see you when we talk about the polynomials in the next video.